So the next thing we're going to do in the unit is use exponential formulas to talk about specific story problems that we can do with these. So we're going to look at the applications of exponential functions. So this is what your page of notes looks like, and we're going to start off, actually let me zoom out so you can see that. So there's all the equations right there. You'll notice that all of them have a y equals, and so the y is the same in every problem. The p is the same in every problem. Anytime you see r, it means the same thing. Anytime you see t, it means the same thing. So what we're going to do is just label what each letter means, and then we're going to do a couple examples using those. So if you look at these problems, the y value is the final amount in the problem. So y is the final amount. In the problem, p is the principal value, and if you're not going to remember what that means, then you can say that p is the initial amount or the starting amount. Next, we have the value for r. R is the rate as a decimal. So this is usually given to you as a percentage, and then you have to move the decimal 2 places to the left to convert it to a regular decimal that we're going to use in the problem. In these equations, t is time, most often years, but sometimes it could be days or hours, depending on the problem. Next, we have this n value, and if you look at all the other equations, n is only found in the compound interest formula, and n is the number of times. You could also say it's the frequency, and this is usually per year. And notice the n shows up in that equation twice. There's 2 n's there, but they're the same number. So if it's quarterly, n would be 4, because that's 4 times a year. Monthly would be 12, because there's 12 months in a year. Daily would be 365. Semi-annually would be 2, because that's twice a year. Annually would be 1, because that's once a year. Okay, next, in compounded continuously, we have the letter E, and if you guys remember, E is a button on your calculator. So you're not actually going to plug anything in for that. You're going to type it into the calculator. There's a button on your calculator. And then last, only in half-life do we have the H, and so H is half-life, which will make sense when we do those problems. So if you're looking at these as a whole, you should see that that a lot of them are very similar to each other. The formula is generally the same, but how we use them is going to be slightly different. Okay, so next what we're going to do is just go through some example problems, not of every type of equation, but for most of them. So this example problem is exponential growth. Go ahead and write on your notes exponential growth. That was the first equation we looked at, and then pause the video so you can write out this problem. All right, so in the problem it says a city has a population of 6,076 in 1990 and grows by 3.7% per year. So the equation we're using is y equals p times 1 plus r to the t, because they are growing each year. And it says how many people are there in 2025. So I'm going to start off by putting my initial value. I don't know my final amount, that's what I'm finding. But I do know the initial value, so that's 6,076. And then 1 plus, and if you remember, r needs to be written as a decimal, so 3.7%. When I write that as a decimal, I just move the decimal 2 places to the left, so this is going to be 0.037. And then to figure out my time, I just have to think about how many years are between 1990 and 2025, and that would be 35 years. So once you plug this into your calculator, you end up finding that the final amount is 21,670.9 0.76 people, and I'm putting approximately there because you can't have 0.76 persons, but we're going to go ahead and write it just to be accurate. And whenever you do these problems, it is always really important for you to put the units so that I know you know what number you just found. So we have to put people on this one. So that's one way that you can use the exponential growth equation. Now go ahead and pause the video, write down this question: how long will it take for the population to reach 25,000? So pause the video, write it down. And to set up this problem, we're going to write 25,000 equals 6,076 times, and if you recall before we had 1 plus 0.037, I'm going to go ahead and simplify that and just add them together. And this time the number that we don't know is the time, because it says how long will it take for the population to reach that. So what we want to do is start moving stuff away from t. So the first thing I'm going to do is divide by 6076, divide by 6076. And I'm hoping that when you guys are looking at this, maybe you'll recognize that this is kind of like those exponential equations where we couldn't get the same base. And if you guys remember, the way that we solve this is by rewriting it as a log. And so this 25,000 divided by 6,076, I don't want to get a decimal for that. Like, I'm not going to plug that in my calculator and get a terrible decimal, because if I round this early in the problem, my final answer is going to be pretty far off. So we're going to leave this 25,000 over 6,076. We're going to leave it just like that. And that's okay. It's not that bad to plug into the calculator. So this is the equation that I have right now. I'm going to convert it into log form. So I'm going to write log with a base of this decimal of this number equals that. And then if I want to solve for t, all I have to do is plug this into my calculator. So once I plug it in, I will find that the time that it takes to get to 25,000 people is approximately 38.93 years. Now, I'm not going to do an example for exponential decay, but go ahead and just write for exponential decay. Oh, that does not have two C's. For exponential decay, you're just going to use a minus, not a plus, in the problem. So we're not going to do an example of that because it's going to be very similar to the last problem that we did. Next, we will do a compound interest problem. So go ahead and write compound interest in your notes. And this is the problem that we're going to be doing. So go ahead and pause the video and write this one down. So in this problem, we don't know the final amount. That's what we're solving. We do know that originally we started off with $7,500. And actually, let me go ahead and write out the equation just in case you don't have it in front of you. Okay. So there's our beginning amount, and then we're going to say 1 plus, and we have the rate written on top of the fraction. And so the rate here, remember, you have to move your decimal over 2 times, so it's going to be 0.0775. This is compounded quarterly, so the n here, quarterly, is going to be 4. Think quarters and a dollar, so that's 4 quarters. So the 4 goes underneath the fraction also as part of the exponent, and then it says after 3 years, so we're going to do times 3. All right, and then when I plug this into the calculator, you can plug it in the way that it looks, basically. So if you wanted to try it at home, it would look like this on your calculator. And then depending on if you have a new calculator or not, you might have to do the 4 times 3 in parentheses. If you have an older calculator and it's going to look like that on the screen, then you have to do it in parentheses. If your calculator bumps it up to an exponent, then you don't have to put it in parentheses. So when you plug that in, we should get that our final amount is approximately $9,442.11. The next question we're going to do with that is how long until the account reaches $15,000. Go ahead and pause the video and write that down. So now I'm going to say $15,000 equals that initial value, which is $7,500. And then in the parentheses, just to make my life a little bit easier, I went ahead and I took this and I plugged it into my calculator. And it's a decimal, but it's not a terrible one. You can actually write it all down. So I'm not rounding it. I do not round these problems until the very end. But I went ahead and plugged that in so that I would have that number there. So I have that to the exponent of 4 times the time. I don't know what the time is, but remember the 4 is from the quarterly. And my goal is to solve for that value for t, so I want to start moving things away from t. So I'm going to divide by 7,500, and I end up getting 2 equals 1.019375 to the 4t. And hopefully now you're recognizing that if we rewrite this as a log, then we can solve this problem. So log is going to have a base of this, of 2, equals 4t. So I'm going to go ahead and I'm going to plug this into my calculator, and whatever decimal I get for that, I will then divide by 4. So when you plug that into your calculator and then you divide by 4, you will find that t is approximately 9.03 years. Now, I don't want to make the video too long, so we do have a couple more examples to do, but we'll do them tomorrow in class so that these can sink in.